Good afternoon and welcome back to today's session. We are still on trigonometry and we want to look at these examples before moving on to the other concepts. In the last video we solved this question sine 120. Well, let's solve it. Let's solve the sine 120. Find the value of sine 120. Now, to find the value of sine 120, we have to first ask ourselves that where does 120 falls? Now, we can see that. So, let's start with sine 120. Sine 120 degrees is an obtuse angle. So it means that it is in the second quadrant. Because it is in the second quadrant, we know that sine is positive in the second quadrant. And the general formula in the second quadrant is 180 degrees minus theta. In this case, theta is the angle that we have here. So our theta here is 120 degrees. Therefore, applying the concept, we can say that sine 120 degrees is equal to sine 120 degrees is equal to, since the question is asking us to find sine 120, so it's equal to sine, then you apply the formula sine 180 minus theta, where theta is 120. So it means that sine 120 degrees is going to be equal to sine 180 minus 120 is 60 degrees. And we know that 60 degrees is a special angle. Therefore, we can say that sine 120 degrees is equal to sine 60, where 60, sine 60 is root 3 on 2. So our answer is root 3 on 2. And it's supposed to be positive. So it is sine 120 degrees should be equal to positive root 3 on 2. And that is correct. Alright, let's look at the next question. II is cos 240 degrees. Cos 240 degrees. So cos 240 degrees, we have to look at 240. Where can we find 240 degrees? Now we know that 240 degrees is in the quadrant third. It is in the third quadrant. It's in the third quadrant. So because 240 degrees is in the third quadrant, that is 240 degrees is in between the angle 180 degrees and 270 degrees. So it is in the third quadrant. And we know that in the third quadrant, cos is negative because the only angle which is positive is tan. Tan is positive. Therefore, cos has to be negative. Then the other aspect is that the formula in the third quadrant, that is when the theta given is a reflex angle, is given as 180 or theta minus 180 degrees. I gave these formulas the other time. I stated here that in the third quadrant, there are two formulas there, 180 minus theta and 180 plus theta. Theta theta minus 180, 180 plus theta. If theta is reflex, then you use this one. So let us take note of that. So we are using the formula 180 minus theta. So it means that our cos 240 degrees is going to be equal to cos 180. So cos theta minus 180, where theta is 240, so it's going to be 240 minus 180. So we are going to get cos 240 minus 180 is 60. So we have cos 60 degrees. And we know that cos 60 is 1 over 2. So the answer is 1 over 2. But the question is that in the third quadrant, it is only tan which is positive. Therefore, because you are looking for cos 240 degrees, the answer has to be negative. So you negate it. Don't forget the negative. Alright. Now, I want us to solve one more. I will solve the IV and we will end this section. So, let's look at sec 120 degrees. Sec 120 degrees is the same as sec is the inverse of cos, or the reciprocal of cos. So sec 120 degrees is the same as 1 over cos 120 degrees. Then we look for cos 120. We know that cos 120 is in the second quadrant, and there only sign is positive. So we can write sec 120 degrees as 1 over cos 120. So we can write it as cos 120 is the same as, in the second quadrant, the formula is 180 minus theta, which is 120. So we are going to get this. But cos is negative in the second quadrant, so you have to negate it. So we have sec 120 degrees to be equal to 1 over negative cos 60 degrees. And we have sec 120 degrees to be equal to 1 over cos 60 is 1 over 2, so negative 1 over 2. So sec 120 degrees is going to be negative 2 as the answer. Now you are welcome back. We are moving on to establishing of some Pythagoras identities. Now let's see, you have a circle with center. Your circle with center. Now we can draw, let's say your radius is this. Then we draw a vertical line. Now this is forming a right angle triangle. We are seeing a right angle triangle here. Now this right angle triangle, let's call this as the radius of the circle R. Now this is the horizontal axis and this is the vertical axis. So we will call this as X and we call here as Y. Now since the triangle is a right angle triangle, then we can apply the Pythagoras theorem. say that x squared plus y squared will be equal to r squared. X squared plus y squared is equal to r squared. You have to also know that, let's say this is your angle, theta. We have already established that we can divide through. Remember that we have already established that cos theta is equal to opposite, which is y, over the hypotenuse, which is r. We established that sin theta, sorry, there is a mistake, cos theta is equal to adjacent, which is x, over the hypotenuse, which is r. Sin theta is opposite, which is y, over the hypotenuse, which is r. And tan theta is equal to opposite, which is y, over the adjacent, which is x. So let's take note of this. Now, coming back to the Pythagorean identity, we can first divide through by x. Let's divide through by s squared. So when we divide through by s squared divided by s squared will give me 1. Then plus y squared divided by s squared is still y squared divided by s squared. Then should be equal to r squared divided by s squared. Now this can be written as 1 plus y over x all squared. Then that should be equal to r over x all squared. Now we can write this one as 1 plus y over x. Now remember that we have y over x to be tan theta, so we write tan theta. Then should be equal to r over x, and r over x here, r over x is the same as the reciprocal of x over r, and we know that the reciprocal of cos theta is sec theta, so we have sec theta. So we have gotten one identity that we have to take note of. Let's take note of this identity. Let's take note of this identity. Now, we can also look at another identity by dividing through by y. This time we are going to divide through by y squared. Divide through by y squared. Now when you divide through by y squared, you are going to get an identity. So when we divide s squared by, so this is our first equation, equation 1. We are dividing through by y squared, so we are going to get s squared over y squared. Then plus y squared over y squared would be 1. Then should be equal to r squared over y squared. When we simplify this, we are going to get x over y all squared, then plus 1. And that should be equal to r over y all squared. Now we know that x over y, we rather have y over x to be tan theta. So it means that the reciprocal x over y is going to be the reciprocal of tan theta, which is cot theta. So this part becomes cot theta. So, but before that, let me correct something. Remember that here, there was a mistake here. y over x is the tan theta, but it is squared, so it was supposed to be tan theta squared or tan squared theta. Let me correct it. Let me correct the mistake here. So we were supposed to get 1 plus y over x. Y over x is tan theta, but because it is squared, it is tan squared theta. Then that should be equal to r over x. R over x is the reciprocal of cos theta, which is going to be sec theta, but it is squared, so it's going to be sec squared theta. So that is going to be the correct identity for this. So we do the same thing for this one. X over y is going to be the reciprocal of y over x, so that is going to be cot theta. Cot theta, but it's supposed to be squared because of the square, so it's going to be cot squared theta. Then plus 1 should be equal to, then r over y. R over y is also the reciprocal of y over r, so it's going to be the reciprocal of sine theta is going to be cosec theta, but it is squared here, so it's going to be cosec squared theta. Cosec squared theta. So that is going to be the identity. So we need to take note of this identity together with this. But even from the very first one, we are able to also generate another identity. Now, we can generate another identity from here. Now remember that cos theta is equal to r sine theta. So it means that from here we can say that r is equal to, or we can make x the subject. X is equal to r. X is equal to r cos theta. Then here to making r the subject, we can say that making y the subject, we can say that y is equal to r sine theta. So we have gotten values for x and y. So we can substitute that into equation 1. Wherever you see x, put r cos theta. Wherever you see y, put r sine theta. So if you do that, we are going to get x. So x is going to be r cos theta all squared. Then plus y, r sine theta all squared. Then that will give us r squared. That will give us r squared. So here we can do some simplification. R squared, this r will affect the square, so it's going to be r squared, then cos squared theta, plus here 2 r squared, then sine squared theta, all divided by r squared. Now we can divide through by r squared. Divide here by r squared, divide here by r squared, divide here by r squared. This will cancel this will cancel this, and this will cancel itself 1. So in all, we are going to get cos squared theta plus sine squared theta, or sine squared theta plus cos squared theta to be equal to 1. And that is also another identity. So there are 3 identities here that we need to take note of. That is this, and this. Now, we can also observe that if I take x over r and I divide by y over r, these denominators will cancel out, and I'm going to get x over y. X over y is the same as, no, let me write it well, let me correct it. Let me rather take this one, the x first. So when I take y over r, which is the sine theta, and I divide by x over r, which is the cos theta, the r will cancel r, then I am left with y over x. We know that y over x is tan theta. what have I done? Y over r, which is sine theta, over x over r, which is cos theta. So basically, I have just divided sine theta over cos theta. And what did I get? I got y over x. And y over x is tan theta. So we can also generalize and see that tan theta is equal to sine theta over cos theta, and that is also another identity. So it means that if you reciprocate, then you are going to get cot theta, which is the reciprocal of tan theta, to be equal to cos theta over sine theta. That is also another identities. Now learn all these identities, 1, 2, 3, 4, 5. Now we can also form another identity, not an identity, but it's a matter of changing subjects. So we can say that sine squared theta from this is equal to 1 minus cos squared theta. And we can still see that cos squared theta is also equal to 1 minus sine squared theta. Let's learn all these identities. They are very important. We shall apply them. Alright. So these are the summary of the basic trigonometric identities. Sine squared theta plus cos squared theta is 1. And also 1 plus tan squared theta is equal to sec squared theta. 1 plus cot squared theta is equal to cosec squared theta. And finally, tan theta is equal to sine theta over cos theta. We can even add some to it, that the fifth one is going to be cot theta is equal to cos theta over sine theta. And even the sixth one, which is cos squared theta, is equal to 1 minus sine squared theta. And finally, sine squared theta is equal to 1 minus cos squared theta. So we need to know these identities by heart. Alright, now let us look at this example. Converting one trigonometric ratio to another. So let's take the example 1. If sine theta is equal to root of 3 over 2, and theta lies in the second quadrant. So let's take note, second quadrant. Then we are to find cos theta and tan theta. Find cos theta and tan theta. So solution. Let's start with sine theta. Sine theta is equal to root of 3 over 2. Now we know that sine theta itself is equal to opposite over the hypotenuse. So it tells you that the root 3 is the opposite of the right angle triangle, and the 2 is the hypotenuse. So if I draw a right angle triangle, then it means that if this is the angle, then it means that my opposite is the root 3 and my hypotenuse is the 2. We are left with the adjacent. We don't know. We can apply Pythagoras to find the adjacent. So we can see that the adjacent, let me call this part A, adjacent. By Pythagoras theorem, adjacent is equal to, or the adjacent, let me use the general formula. So by the Pythagoras theorem, we know that hypotenuse squared is equal to opposite squared plus adjacent squared. So we know our hypotenuse to be 2. So 2 squared should be equal to opposite squared, which is root 3 squared, and plus adjacent squared. 2 squared is 4. Root 3 squared is 3, then plus the adjacent squared. So our adjacent squared is going to be equal to 4 minus 3. Then we have adjacent squared should be equal to 1. Therefore, our adjacent will be root of 1, which is 1. So it means that our A, which is the adjacent, is 1. Now, let us start with the solution. The question says that find cos theta and tan theta. So let's start with cos theta. We know that cos theta is equal to adjacent over hypotenuse. So what is adjacent? Our adjacent is 1, and our hypotenuse is 2. But we know that theta lies in the second quadrant. If theta lies in the second quadrant, we know that only sign is positive. You have to learn the cast diagram very well. In the second quadrant, sign is positive, but this time it is cos. Therefore, cos must be negative, but theta lies in the second quadrant. Therefore, cos is negative. So the final answer should be, this implies that cos theta should be equal to negative 1 over 2. And that is the answer. That is the answer. Now let's go to tan theta. So tan theta is also opposite over the adjacent. We know our opposite to be root of 3, and our adjacent is 1. So we can say that tan theta is equal to root of 3. But is tan positive in the second quadrant? No. Tan is also negative in the second quadrant. Therefore, tan theta must be equal to negative root over 3. And that is the solution to this question. That is the solution to this question. Now we can apply another method to solve it. Well, I don't want us to use it, but for the sake of learning, I'll use it for this. But as time goes on, I will stick to this approach. Now let's see, we want to solve the same question. I'll go by this approach using the identities. Now we have been given that sine theta is equal to root of 3 over 2. So the first step is I'll square both sides. Then I'll get sine squared theta. Sine squared theta is equal to 3. Root of 3 squared is 3 over 2 squared is 4. So I have sine squared theta to be equal to 3 over 4. But we know that sine squared theta using the identities is equal to 1 minus cos squared theta. We just learned that. Sine squared theta is equal to 1 minus cos squared theta. So from here, we know that sine squared theta is 3 over 4. So we can write as 3 over 4 should be equal to 1 minus cos squared theta. Then we group like terms. So cos squared theta will be equal to 1 minus 3 over 4. So we have cos squared theta to be equal to 1 over 4. Now I can square root both sides. Square root both sides. Anytime you square root both sides, remember you bring your plus or minus. The square will cancel the square root. So I have cos theta should be equal to plus or minus root of 1 over 4 is 1 over 2. So here we are having two values, positive and negative. So we say that since cos theta is in the second quadrant, it has to be negative. Since cos theta is in the second quadrant, it implies that cos theta is negative, so negative 1 over 2. And that is the answer. Now, we can still apply the fact that tan theta is equal to sin theta over cos theta. We have it here. Sin theta, tan theta is equal to sin theta over cos theta. So now, this means that sin theta, what is sin theta in the question, is root 3 over 2. Then the cos theta, we now have it to be negative 1 over 2. So when you solve this, the denominators will cancel denominators. Then we are left with root 3 over negative 1, which is negative root of 3. Therefore, tan theta is negative root of 3. And that is the answer. So there are two ways of solving it. Either you use this approach or you use this approach. Any of them is correct. Now let's move on to the next example. Find without using tables the values of cos theta and tan theta if sin theta is 5 on 13. So solution. We know that sin theta is equal to 5 on 13. I'm using just one method. You can use the other method. So let's see. We have the angle to be here, theta. It means that sin theta is opposite over hypotenuse. So our opposite is 5. And our hypotenuse is 13. So we can work out for the adjacent. Now, we all know how to work with Pythagoras theorem, so I will be skipping some of the methods. So it's just going to be 13 squared minus 5 squared. And that is going to be root of 144, so we will get 12 as the adjacent. We will get 12 as the adjacent. So that's going to be 13 squared minus 5 squared, and we have the square root of the answer to be 12. So our adjacent is 12. So quickly we can start with cos theta. We know that cos theta is going to be equal to the adjacent over the hypotenuse, and the answer is going to be 12 over 13. But remember that here we were not specific. Find without using tables the values of cos theta and tan theta. We have gotten cos theta to be equal to 12 over 13. But even though they didn't specify that theta is in the first quadrant or the second quadrant, so what do? It means that since you have gotten cos theta to be root 3 over 13, you know that cos theta, here they gave us that sin theta is equal to 5 on 13. If sin theta is 5 on 13, it means that here sin theta was positive. So it means that where is sin positive? Sin is positive in either the first quadrant or the second quadrant. So this will give you a clue that because sin theta is positive, then it means that theta is in the first quadrant or the second quadrant. So what is happening? So it means that since we are getting cos theta to be 1 over 2 over 13, we know that cos theta is going to be in the first quadrant or the second quadrant. So here cos theta is equal to 12 over 13 is correct because it is in the first quadrant. It is in the first quadrant. So that is 12 over 13. That is when cos theta is in the first quadrant. But it can also be in the third, it can also be in the, remember that here, since we know that we are working in the first quadrant and the second quadrant. Now, because cos theta, we have gotten cos theta to be 12 over 13, it is, if it is in the first quadrant, then it is positive. But when it is in the second quadrant, it will be negative because cos is not positive in the second quadrant. Therefore, we can say that cos theta can also be negative 12 over 13 in the second quadrant because we are working in two quadrants. If it is in the first quadrant, it is positive, that is 12 over 13. But if it is in the second quadrant, cos theta has to be negative. So these are the two solutions for cos theta. That is when sin theta is positive 5 over 13. It means that sin is both in the second quadrant and the first quadrant. Therefore, cos has to also be in the first quadrant and the second quadrant. Cos will be positive in the first, but in the second quadrant, cos is negative. So that is the solution. So now, we want to find tan theta. We were asked to find cos theta and tan theta. So now tan theta. We know that tan theta is also opposite over the adjacent. The adjacent. So our opposite, as we know, is 5. And our adjacent is 12. So we have tan theta to be equal to 5 over 12. But also, take note that we are still using the condition that the angle is in the first and the second quadrants. We know that for the first quadrant, tan is also positive because all are positive. So we can say that tan theta is equal to 5 over 12 in the first quadrant. But in the second quadrant, tan is not positive, it is negative. And tan theta is equal to negative 5 over 12 in the third quadrant. So these are the two solutions for tan theta. Now let's move on to another example. Find without using tables the values of sin x and cos x if tan x is 1 on 3. Solution. But here it has been indicated that x is acute. So we know that we are working only in the first quadrant. Now if tan x is given as 1 over 3, we know that tan is opposite over the adjacent. So when you draw your right angle triangle, and the angle here is theta, then the opposite has to be 1 here. The adjacent is 3. So we need to work for the hypotenuse. We know that the hypotenuse is always the opposite squared. So the hypotenuse will always be the square root of opposite squared plus the adjacent squared. So our hypotenuse is going to be 4, 3 squared is 9, plus 1 is 10, root of 10. So we have root of 10. That is our hypotenuse. Now we are asked to find sine s and cos s. So let's start. Sine x is given as opposite over hypotenuse, and that is equal to 1 over the root of 10. We can rationalize as root 10 over 10. That is if you want to rationalize. Now cos x is also equal to adjacent over the hypotenuse. And we know that the adjacent is 3 and the hypotenuse is still root of 10. That is the answer, or if you like, you rationalize. In rationalizing, multiply the numerator by root 10 and the denominator by root 10. So you have 3 root of 10 all over root of 10 times root of 10 is 10. And that is the answer. So that is all about this type of questions. Always draw the right angle, indicate the sizes, and apply the trig ratios, that is the SOHCAHTOA, well, and also consider the cast diagram to know the signs which are applied. Now remember here it was acute angle, so both sine and cos and even tan are all positive, so they are all positive. You don't do anything to it. Alright, now let's also look at this type of question. Here we are trying to simplify trig identities. So we have 1 over 1 minus cos theta plus 1 over 1 plus cos theta. For you to be able to solve these questions, you have to go back and revise the identities. Your basic identity is that sine squared theta plus cos squared theta is equal to 1. And we can also get cos squared theta or sine squared theta is equal to 1 minus cos squared theta. And we also know that cos squared theta is equal to 1 minus sine squared theta. You need these 3 basic identities. You also have to know that tan theta is equal to sine theta over cos theta, and cot theta is cos over sine. Know these basic identities as we have done them already. So here we are to simplify. So there are ways of simplifying it. We can first find our LCM. Find your LCM. Your LCM is going to be 1 minus cos theta multiplied by 1 plus cos theta. So when you factorize 1 minus cos theta, you have 1 plus cos theta times 1, which is still 1 plus cos theta. Then plus factorize 1 plus cos theta, you have 1 minus cos theta. So here we can see that cos theta minus cos theta will go away. So we are left with 1 plus 1, which is 2, all divided by. Now, we know from difference of two squares that if you have, let's say, 1 minus x, 1 plus x, it is the same as 1 squared, which is 1, minus s squared, which is s squared. This is difference of two squares. We can apply the same thing here. So since we have 1 minus cos theta, 1 plus cos theta, it can be written as 1 squared, which is 1, minus cos theta squared, which is cos squared theta. Then also we know that 1 minus cos squared theta is sine squared theta. So we can write this one as 2 over sine squared theta. Then we can write it as 2. Factorize the 2 out. You will be left with 1 over sine squared Then it is the same as 2 into bracket 1 minus sine square theta is the same as 1 over sine theta all squared. Because 1 over sine theta squared is the same as 1 squared 1, and sine theta squared is sine squared theta. Now remember that 1 over sine theta is just the reciprocal of sine, and the reciprocal for sine is cosec theta. So cosec theta. So it means that we can write this one as 2 cosec theta. Cosec theta. 2 cosec theta all squared. And that is the same as 2 cosec squared theta. Cosec squared theta. And that is the answer. That is the answer. Alright, so we can look at another example. Simplify. Now look at this and look at this. They are almost the same, just that it has changed. So I will not worry myself to solve. I'll give you the answer. When you solve this, you will get 2 sec squared theta. Try it. First, find the LCM and apply the same concept that we used here. It's a similar question, so I don't want to repeat it. Let's go to this. Prove that cot A minus 1 over cot A plus 1 is equal to 1 minus tan A over 1 plus tan A. Now we are going to start with the left hand side, which is cot A minus 1 over cot A plus 1. Now remember that cot A is the same as 1 over tan A. That's the reciprocal of tan is cot. So we can rewrite this one as 1 over tan A minus 1, and all divided by 1 over tan A plus 1. Now we have both the numerator. This one is also over 1, and this is also over 1. So we can find the LCM for both the numerator and the denominator. So we can have, let's focus on the numerator. For the numerator, our LCM is tan A. Tan A. So for the tan A, we will get factorize tan A. We have 1 minus factorize 1, we have tan A. Then we also come to the denominator. This time we still have tan A. Factorize tan A, we have 1 plus factorize 1, we have tan A. Now the denominators are the same, so they will cancel out. Then we are left with 1 minus tan A all over 1 plus tan A. That is the answer to the right hand side. Next question. Prove that sec A minus tan A. Prove that the square root of 1 minus tan A over 1 plus tan A is equal to sec A minus tan A. So we still focus on the left hand side, which is the square root of 1 minus sine A all over 1 plus sine A. So here what I'm going to do is that I am going to extend the root and multiply both sides by the conjugate. Or I'll multiply the denominator by 1 minus sine A. Then I'll do the same thing to the numerator, 1 minus sine A, like this. Since I have multiplied both the numerator and the denominator by the same value, it will not change anything. It won't change anything. Now let us simplify. We have the square root of, so let's focus on the first one. We have 1 minus sine A, 1 minus sine A, which can be written as 1 minus sine A. They are the same, so we can square it. Then all over. Here we have 1 plus sine A, we have 1 minus sine A. This one is a difference of two squares. So we can take the negative 1 and square each of the terms. So 1 squared is 1. Then minus sine A will become sine squared A. That is difference of two squares. Okay. Then we continue. Now, the square root is affecting both the numerator and the denominator. We have square root of 1 minus sine A, all squared. Then all divided by 1 minus sine squared A is the same as cos squared A. Cos squared A. Now, we can take it as square root of, we are going to take them one by one. So square root of 1 minus sine A, all squared. Then divided by another square root of cos squared A. Cos squared A is the same as cos A, all squared. So you can write it like this. Then remember that the square root will cancel this square, and the square root will also cancel this square. So we are left with 1 minus sine A all over cos A. Cos A. So that is going to be the answer. But we are not done. Now remember that if you have 1 minus sine A all over cos A, we can split it into two, as the cos A is dividing 1 and sine A, so we can write it as 1 over cos A, then minus sine A over cos A. But we know that the reciprocal of cos is sec. So 1 over cos A is the same as sec A. Then minus sine A over cos A. We just studied that sine over cos is tan. So we have tan A. And that is exactly what we have here. So the solution is sec A minus tan A. Now let's look at a particular question from the slide. Verify the identity. So it means that show that this is equal to this. So let's start with sec A. Sec alpha minus cos alpha. We have to show that it is equal to sine A tan A. Now we know that sec A is the same as 1 over cos A. You have to learn the identities very well. Then minus cos alpha, which is the same as cos alpha. We don't do anything to it, but it is over 1. It's over 1. Now, we can find our LCM. Let's find our LCM. LCM is cos alpha. When you factorize cos alpha, you have 1. Then minus, when you factorize 1 out, you still get cos. So you're going to get cos alpha times cos alpha, which is the same as cos alpha times cos alpha. So we are going to get this. But remember that our focus is to get sine alpha tan alpha. So where I am going to head towards, I don't think I'll get the sine alpha tan alpha here. Let me use a different approach. Alright, so let's start all over. We are given that sine alpha minus cos alpha is equal to sine sec alpha minus cos alpha is equal to sine alpha tan alpha. So let's follow the same steps again. Sine alpha minus cos alpha. We know that, this part is sec alpha. Sec alpha minus cos alpha. We know that sec alpha is the reciprocal, that is 1 over cos alpha, and minus cos alpha. Remember that this is the same as over 1. So our LCM is cos alpha. When you factorize this out, you have 1. Then minus, when you factorize this, you get cos alpha times cos alpha, which gives you cos squared alpha. We know that 1 minus cos squared alpha is the same as 1 minus cos squared alpha is the same as sine squared alpha. Sine squared alpha by the identities all over cos alpha. Now when we get to this point, we can split it into 2. Sine squared alpha means sine alpha times another sine alpha, then all over cos alpha. Now let's take note that if you have, for example, 1 times 2 all over 3, it is the same as writing it 1 over 3 times 2, or you can even write it as 1 times 2 over 3. The denominator is affecting all of them, but when you are writing, you can use it to affect only one. So you can either write it as 1 over 3 times 2 or 1 times 2 over 3, but you cannot write it as 1 over 3 times 2 over 3. This is wrong. So let us apply the concept here. So it means that if you have sine alpha times sine alpha all over cos alpha, then we can write it as sine alpha, then times another sine alpha times another sine alpha over cos alpha. So we can write it like this. This and this, they are the same. Then I can write it as sine alpha times sine alpha over cos alpha is tan alpha. So that implies that the final answer is going to be sine alpha tan alpha. That is the solution to this question. Now verify the identity. Sec theta is equal to sine theta into bracket tan theta plus cot theta. Now we can see that the left hand side is very simplified, but the right hand side is more complex. So we rather start with the right hand side to get the left hand side. So you can solve it like that. Anytime you have an identity, look at the more complex parts, you can simplify that part to get the very simple part. So I'll start this time with the sine theta into brackets tan theta plus cot theta. Then I know that sine theta, tan theta is the same as sine theta over cos theta. Then also cot theta is the same as cos theta over sine theta. Now I can multiply through by sine theta. So if I multiply through by sine theta, I'm going to get sine theta times sine theta will give me sine squared theta. Sine squared theta all over cos theta. Then plus. When I multiply here, I'm going to get sine theta will cancel sine theta, so I'll get cos theta. I'll get cos theta. Now remember that this one is over 1. Now I can find my LCM to be cos theta. When you factorize cos theta, you will still get sine squared theta plus. When you factorize 1 out, you get cos theta times the cos theta will give you cos squared theta. Now we know that sine squared theta plus cos squared theta by the identity is 1. So all this expression is equal to 1. Is equal to 1. All divided by cos theta. And we know that 1 over cos theta is sec theta. Sec theta. And hence the answer. So that is it by identities. Now let us try with the last one. Let's try with this last example. Verify the identity. So here we can start with the very first one. Cos x all over 1 minus sine x. Now I will multiply the denominator here by 1 plus sine x, the conjugate. Then I'll do the same thing for the numerator, which is 1 plus sine x. It means that I have not done anything to it because they can cancel. Now let us expand. Cos x times 1 is cos x. Then plus cos s sine x. Cos x sine x. Or let me rather put it this way. I will not expand for now. Let me leave the numerator as cos x into bracket 1 plus sine x. Then let me rather focus on the denominator. Now, here we have 1 minus sine x, 1 plus sine x, which is the same as 1 squared minus sine squared x. Remember that 1 squared is the same as 1, so you can just write it as 1 minus sine squared x. But we know that 1 minus sine squared x is cos squared x, so we can write it as cos x into bracket 1 plus sine x, all divided by cos squared x. So we have cos x into bracket 1 plus sine x. And we know that cos squared x is the same as cos x times another cos x. And we can cancel 1 of the cos x. So we are left with 1 plus sine x all divided by cos x. Cos x. And that is the answer to the question. So we are done with the identities. Thank you for watching the video. Try and go through them very well. Understand it well. We shall continue from here. Bye bye.